Hi everyone, today's lesson is a chapter review for coordinate geometry. So let's get started. Starting with coordinate proofs, if we want to prove that segments are congruent, then we are going to use the distance formula. And the distance formula is distance equals the square root of subtracting your x's, quantity squared, plus subtracting your y's, quantity squared. And this is given. That's if you were given 2 points. Point 1 would be x1, comma, y1. And point 2 would be x sub 2 second x, comma, second y. In order to prove that segments bisect each other, what you need to remember is if you have any shape and you want to know if the segments bisect each other, these two shapes in the segments are going to have the same midpoint if they bisect each other. So what you're going to use is the midpoint formula, and given that midpoint formula, that's going to tell you whether or not these two segments bisect each other in this shape. So the midpoint formula is again given 2 points, x1, y1, x2, y2. So to find the midpoint, xm, comma, ym, you're going to say, well, I'm going to add my x's together. So x1 plus x2, it's the average, and find the average. So divided by 2. And then y1 plus y2 divided by 2. To figure out if lines are parallel, well, parallel lines have the same slope. Okay, so if you have two parallel lines, they have the same slope. So in order to find the same slope, you're going to subtract your y. So slope equals subtract your y's, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And if you're trying to show that two lines are perpendicular, then what they're going to have is the opposite reciprocal. What that means is you're going to find the slope. So first find the slope. And second, you need to figure out if they're opposite reciprocal. So for example, if I said that my slope, after I used the slope formula, was, let's say, 5. The slope of the line that's parallel will be the same thing because parallel lines have the same slope. But if you're trying to find the parallel or the perpendicular line, slopes have what's called the opposite reciprocal. So you're going to take 5. You know there's a 1 underneath that. So the opposite meaning opposite, negative. If it's negative, it'll be positive. And then the reciprocal is this flipped upside down. So now it's negative 1/5. Let's do another one. For example, if I said that my slope was negative 1/2. Okay, if my slope was negative 1/2, the slope of the line that's parallel to that is going to also be negative 1/2. And then the slope of the line that's perpendicular to that is going to be the opposite reciprocal. So that means we're going to flip it upside down. So now it's 2 over 1, and it's the opposite. So if it's negative, now it's positive. And a trick here to show if something is perpendicular also is it's the product of the slope. So for example, if I take my slope, the original slope, which was negative 1/2, so negative 1/2, and I multiplied it by my perpendicular slope, which I think is 2, when I multiply these together, and you should cancel, 2 divides into 2 once. When I do that, I end up getting negative 1 times 1. If your product is negative 1, then the lines are perpendicular. So if I just came up and said, my slopes are 3 and my other slope is going to be 1/3, are these perpendicular? The answers would be no, because when you multiply these out, you get 1. And 1 is not, the product of the slopes is not negative 1. So they're only perpendicular if the product of the slopes are negative 1. So this first coordinate proof that we're going to review says the median drawn to the legs of an isosceles triangle. Now, what you need to remember about a median is in a triangle, a median would be found by first finding the perpendicular bisector, where this is congruent to that. So this means this is the midpoint. And step 2 would be connect your vertex to that midpoint. So I would need to find the midpoint. And then if they want to know if my lengths are congruent, I would need to find the length of the median, okay, on both sides. So let's draw that triangle on our axis. So it's an isosceles triangle. So what I'm going to do is, let's see, I'm going to try to make this even. Okay, so there's good enough going across like that. We're going to call this point up here 0, comma B. So this point is 0, 0. It's isosceles, so that means two sides are congruent. Also, this is going to be A, comma 0. This point is going to be negative A, comma 0, because this distance is the same as this distance here, negative A, comma 0. Okay, so the first thing we need to do is we need to find the midpoint, because my median from the two other sides, the two angles, are going to be from here to here and from here to here. Those are going to be my medians. But before I find my medians, I have to find the midpoint is first. So the midpoint of this segment right here. It would probably be helpful if I labeled these. So this would be, let's say that's A, this is B, this is C, this point C. So I want to find the midpoint. So the midpoint of AB. So that's going to be 0 plus A divided by 2, comma, 0 plus B, or B plus 0, 0 plus B divided by 2. And so that's actually going to be A over 2, comma, B over 2. So that's my midpoint. So that point right there is parenthesis A over 2. So A over 2, comma, B over 2. And then this midpoint right here for AC, so the midpoint of AC is going to equal, parenthesis, add your x's up, divide by 2. So 0 plus negative A divided by 2. And we have B plus 0. So 0 plus B divided by 2. And that's going to equal negative A over 2, comma, B over 2. So that's what these 2 points are. So this point, let's put it in blue. Over here is my midpoint. These are both my midpoints. This point is going to be negative A over 2, comma, B over 2. And this midpoint, let me fix that just a little bit. This midpoint here is A over 2, comma, B over 2. All right. So now that we found the midpoints, we know that our medians are going to do this. That value goes to that, and that goes to that. Now we need to find the distance of those two. So for me to find the distance for these right here, I'm going to find the distance. And distance formula, we're going to say subtract your x's. So I'm going to have negative A minus that. A over 2, quantity squared, plus, now subtract your b's, 0 minus b over 2, which is just negative b over 2, quantity squared. Now the other distance, I'll put that in green. So this one right here is what I'm looking for now, that distance. And so I'm going to subtract, so distance equals, I'm going to go square root of, okay, negative a over 2, negative a over 2 minus a, quantity squared, plus b over 0 minus, what is that? What did I just do? This minus this and this minus this. So that'll be b over 2 quantity squared. Keep in mind, see this one right here? See how these are both the same, but this one here is not. However, when you square a term that had like this, it's negative b over 2 times negative b over 2. That's going to make that positive. So that value right here, I could actually rewrite as the distance is equal to parentheses negative a minus a over 2, which you don't need to simplify that, plus b over 2 quantity squared. And these two right here are equal. So therefore, if the medians are congruent or equal, then the median lengths are congruent, then they are congruent. So if the median lengths are equal, then the two lines are congruent. Done. All right, cool. The next question says you're given these points and your job is to prove that it is a rhombus. So let's see what we got. We know that we have 0, 0, so A is 0, 0. We know B is 5, 0, 2, 3, 4, 5. Is that right? 1, 2, 3, 4, 5, 0. So that's B. We know C is 8, 4, so 5, 6, 7, 8, 1, 2, 3, 4. So that's C. And we know that D is 3, 4. So 1, 2, 3, 1, 2, 3, 4. So this is D, which is 3, 4. So a couple of things. First of all, in order to show, there's a couple of things that tell some whether or not it's a rhombus and whether or not, what are the characteristics of a rhombus? Just for review, some characteristics of a rhombus is that, number one, it has 4 congruent sides. Okay. Number two, let's see here. Well, of course, it has all the characteristics of being a parallelogram. But if we can prove that all 4 sides are congruent, then we can prove it's a rhombus. Because even though the 4 sides are congruent, that doesn't make it anything else. Like, it doesn't make it a square or anything. It just makes it a rhombus. In addition to that, you know that the diagonals are congruent. No, diagonals are not congruent. Silly. Diagonals are perpendicular. Okay. So I could show that the slopes are opposite reciprocals of each other. Number 3, I could show that both pairs of opposite sides are congruent. And so both pairs of opposite angles are congruent. But that's a characteristic of basically a parallelogram. So that's not unique to being a rhombus. So I have these 2. I'm trying to think if there's anything else that I want to do, and I don't think so. So what I'm going to do is I'm going to prove that the 4 sides are congruent. So we know that DC, the length of DC, is just 1, 2, 3, 4, 5 units. We don't even have to use a distance formula for that. We also know that the distance of AB is equal to 1, 2, 3, 4, 5 also. Okay, so we know for sure these 2 segments are congruent. So the next thing I'm going to do is I'm going to try to prove that these lengths are also congruent. Now, you can use the distance formula. So if I use the distance formula for BC, I'm going to find the measure of BC using the distance formula. Subtract your x's. So I'm going to go 8 minus 5 quantity squared plus 4 minus 0 quantity squared. So what that's going to give me is 8 minus 5 is 3. 3 squared is 9. 4 minus 0 is 4. 4 squared is 16, which gives me the square root of 25, which is equal to 5. Keep in mind, you never, never, ever want to split these up. You should know that the square root of 9 plus the square root of 16 is not the same thing as 9 plus 16 underneath a root. Okay, just keep that in mind. For thought, you cannot split those up. Anyway, so now we have another 5. So we know that this length is also 5. And also, actually, 2 consecutive sides that are congruent make a rhombus. So if I know that length is 5, that length is 5, now it's a rhombus. But just to finish what I had said, I'm going to prove all 4 sides are congruent. And I could use the distance formula, but just another alternative is to create a right triangle out of this and make this into Pythagorean theorem. And so we know that this length is 1, 2, 3, 4, and this length is 1, 2, 3. So I could use Pythagorean theorem to find this third side, and I could go 3 squared plus 4 squared is equal to this side squared. I'll call it the whatever distance squared. So we have 9 plus 16. Getting rid of this square, we're going to square root both sides, and we get the square root of 25, which is 5. So I also know that that length is 5. So therefore, therefore, the quadrilateral is a rhombus because it has 4 congruent sides, which in fact, remember, you only needed if two consecutive sides are congruent, then it's a rhombus. So we actually could have stopped right after we found BC. All right, the next question says, write an equation of a circle that has a center of -3, 1. So 1, 2, -3, 1. So here's my center right there at -3, 1. It passes through the point 5, -3. So we have 1, 2, 3, 4, 5, 1, 2, 3. So it passes through this point, which is 5, -3. And so what that means is, what that looks like is that your circle passes through that. So it goes something like that. It passes through that point. And then, of course, comes around something like that. But it passes through that. So you need to draw it right in order to get this problem right. That makes this length right here a radius. So that's my radius, okay? A couple of things. In order to find the length of that radius, I definitely can make this into a right triangle and use Pythagorean theorem. Or I can just use the distance formula to find that length. But remember, the equation for a circle is going to be, well, it's going to be given HK, and HK is my center. So given my center, the equation of my circle would be the quantity x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. So given the point -3, 1, see this minus sign here? What that does is it gives me the it's telling me you're finding the opposite. So really, it's going to be x plus 3. So x plus 3 quantity squared plus, there's your y coordinate. That goes with x, that goes with y. Plus y minus 1 quantity squared is equal to my radius squared. I haven't figured out the radius yet, so let's do that next. So in order to find the distance between those 2 points, again, of course, you can use Pythagorean theorem, but I'm actually going to just use the distance formula, which says subtract my x's. So I'm going to go -3 minus 5. -3 minus 5, be consistent when you subtract the other. So you're going to go 1 minus -3. So plus 1 minus -3 quantity squared. So my distance between the 2 points is going to be -8 squared. The -8 squared is going to be positive 64 plus, these make plus, so that's 4 squared, which is 16. So 64 plus 16 is 6, 7, 80. So this is the square root of 80. And so before you start reducing that, because you're like, oh, there's the radius, I got to start breaking this down into, whatever you're going to break this down and keep going, stop. Because what goes here is r squared. And if this is my radius, okay, I need to square that. And when I square that to get this value here, this root is going to go away. So my final answer is going to be the quantity x plus 3 squared plus the quantity y minus 1 squared is equal to 80. Okay. The next question says, write the equation of a circle that has endpoints of its diameter, this. So let's get that graph. So what I'm going to do is I'm just going to borrow this graph and bring it over here. There we go. Kind of a visual person here, so I do want to definitely graph my circle so I can see what I'm dealing with. The first point is -1, 5. So over 1, 1, 2, 3, 4, 5. So here's this point right here. That point is -1, 5. The other point is 5, 11. So 1, 2, 3, 4, 5. I think this is 10. Plus 1 is 11. So this is 5, 11. So what this is what is that? That's my diameter. And so what you're going to do with that is, let's try to graph this. So my circle, if that's my diameter, that means that my circle comes around like this and comes through like that. So that's my circle. So given that information, I need a center. So to find the center, it might be right there, but in order to be sure, I'm going to use my midpoint formula to find the midpoint, or to find the center. So to find the center, I'm going to say -1 plus 5 divided by 2, comma, and then I'm going to add my add my y. So 5 plus 11 divided by 2. So what does that make? The center is going to be at -1 plus 5, which is 4. 4 divided by 2 is 2. 16 divided by 2 is 8. So at 2, 8, right around there, which is kind of what I thought in the beginning. But anyway, there's 2, 8. So that's my center. So that means that once I start writing my equation, I can actually start going x minus 2 quantity squared plus y minus 8 quantity squared equals my radius squared. So in order to find my radius, I need to find the distance between here and here. Now, I have a choice. I can actually find the distance between 511 and -1,5, get that number and divide by 2. Or I can just find my distance between these 2 points. So I'm actually going to choose that, and I'm going to choose this radius from here to here, from here to here. Okay, so we're going to find that distance, which is my radius. So subtract my x's. So I have parentheses 5 minus 2 quantity squared plus 11 minus 8 quantity squared. So I have 3 squared, which is 9, plus 11 minus 8 is 3. 3 squared is 9. Square root of 9 plus 9 makes square root of 18. And again, this is my radius. So my radius is the square root of 18, and I know that that breaks down. But don't do that, because again, I'm looking for r squared. And so what I want to do is take this number here and square it in order to find r squared. So my final answer is x minus 2 quantity squared plus y minus 8 quantity squared is equal to 18. And that's my final answer. Okay. So this question says, put the equation of the circle in standard form. Now, the trick to this is that in order to put it in standard form from general form, this is general form, you're going to do what's called complete the square. And I know we've been practicing this in the previous lessons, but let's get started with this. So we have x squared, group your x's. So x squared minus 6x. And then I'm going to leave a space here, and then I'm going to go plus y squared, and where's my other y? There it is, minus 22y. I'm going to take this number, 121, and move it to the other side of the equal sign. So now it's negative 121. So what I'm going to do now is I'm going to complete the square, but I realized just now I didn't leave a space there. Okay, so what I'm going to do here is, in order to complete the square, we're going to take half of the b term, so half of -6, which is 3. 3 squared, which is 9. And whatever you add to one side, remember, you do need to add it to the other side. Because it is an equation, it's an equal sign. So it's equal. Left side equals right side. So if you do something to the left side, you're going to add something to the right side as well. Again, complete the square, take half of the b term, which is -22, half of that, which is -11. You're going to square that, and you get plus 121. So what's going to happen here is, did we add 121? No, we didn't. So if you add 121 here, you better add 121 here. So now I need to factor this and this. We just completed the square. Now we're going to factor. So factoring this, we get x minus 3 times x minus 3 quantities, or excuse me, x minus 3 times x minus 3, which is rewritten as x minus 3 quantity squared, because there are 2 of those. And then this one is going to factor to be y minus 11 times y minus 11. And that's going to simplify to be y minus 11 quantity squared. 121s are going to cancel, and I end up getting 9. So this right here is my equation in standard form. Keep in mind that the center is going to be 3, 11. My radius, remember, this is r squared, which means that my radius is going to be the square root of 9, which is 3. So my radius is 3. So that if I wanted to, I don't know, graph this, I would go over 3 and up 11. Let's say that's where that is. There's 11. There's my center. And my radius is 3. So my so my graph would actually be this little circle right here, sort of floating up in the air. Okay. Use coordinate geometry to prove that the diagonals of a square are congruent. Well, okay. Let's. I guess we can grab I guess I can grab this again. Let's see. Here's my picture again. Let's see here. Closing this up. Okay, let's make a square on this. Okay, so in doing this, I'm going to put it right on the axis. Here's 0, 0. Let's make our square I don't know. I want to make it 4 units. So 1, 2, 3, 4. 1, 2. Okay, let's see here. 4. 1, 2. I guess they're not asking you to use numbers. What should we call this? A. Let's call this A. So let's say, because a square has all 4 sides are congruent, let's call this A0. So then we go over A. That means we have to go up A. So now that's going to be A, comma A. And this is going to be, we didn't move over, we just went straight up. So that'll be 0, A. So in order to prove that my diagonals are congruent, I'm going to find the distance between these 2 lengths. Now, again, Pythagorean theorem's totally fine, but I'm just going to find the distance. So the distance from this to this, okay, is going to be distance from those 2, from these. Okay, let me color it. We're going to use, this one's going to be blue. The other one's going to be a different color. So we're going to go the square root of, subtract your x's, so 0 minus a quantity squared, plus subtract your y's, a minus 0 quantity squared. And in doing that, we get, let's see here, we have 0 minus a, which is negative a. Negative a squared is a squared, plus a minus 0 is a squared is a squared. Oh, well, we have a squared plus a squared is 2a squared. Keep in mind that's under the root. Now, this is the same thing as saying the square root of 2 times square root of a squared. Well, the square root of a squared is a. So what we have is a root 2. Remember, before I told you that you couldn't split values up. Remember we had this example, 9 plus 16. We said that does not equal that plus that. And that's still true. What I want to remind you is if I had had 9 times 16, multiplication, product, that does equal the square root of 9 times the square root of 16, okay? So that's just something to keep in mind. That's totally fine. So my blue diagonal, this one right here, is a root 2. And let's just say some people may not know where this a squared, why did the root just disappear on the a? Well, something to remember is this, a root is a half power. See that root? So, for example, a root is a half power. So if I said x, the square root of x, we don't see a little 1 there, and we don't see the little 2 here. But this is actually x to the 1/2 power, okay? So what we had here was this root, okay? And we had this root with a squared underneath it. And what that meant was this a squared is here, a squared. And I just told you that a root, this root right here, is a half power, 1, 2. So what it's really saying is a squared to the 1/2 power. These 2's are going to cancel, and you get a by itself. That's why this a right here came out of that square root, okay? Same thing goes for, like, I don't know, the square root of 49. you can write it as 7 squared, but the square root of 7 squared. Well, that's the same thing as saying 7 squared. That's what's inside. And then you have this root, and that root is a half power. So that's to the 1/2 power. Well, 2's are going to cancel. You end up getting 7. So the square root of 49 is 7 because of that. So anyway, that's kind of cool. Okay, so we need to find the other side. Okay, so I'm going to use, let's use red. I think you're going to be able to see red. We need to find the distance of this because we're trying to prove that the diagonals are congruent. So let's try to do that. 0 minus a, so 0 minus a quantity squared plus subtract my y's, 0 minus a, 0 minus a quantity squared is going to be the square root of negative a times negative a, which is a squared, plus negative a squared is another a squared. A squared plus a squared is 2a squared. And again, that's the square root of 2 times the square root of a squared. And the square root of a squared is a. Square root of 2 is root 2. And so my two lengths are congruent. So remember, you always want to make a conclusion whenever you're making proving a coordinate geometry proof. So there, you would say, therefore, if both of the diagonals have equal measure, then the diagonals are congruent. Okay? So this one is asking, given a point and a slope, find the equation of the line in standard form. Well, if I have a point and I have a slope, I'm going to use point-slope form. And if you remember what point-slope form is, that is when you have, you're given a point and a slope. Okay, so the equation would be y minus k is equal to my slope times x minus h. And hk is the point that they gave me. So we're going to say, we're going to start off with y minus negative 2. So that's y plus 2 is equal to the slope times x minus h, which is 5. That's hk. X minus 5. Because remember, it's the opposite. See that minus h, opposite of h? That's where that came from. To put it in standard form, if you remember what that is, standard form looks like this. ax plus by is equal to c. This is where a is a positive integer. And that being the case, you can't have it's not a fraction. Okay, so let's solve for y. So y is equal to, see this plus 2? That's going over to the other side, way over here. Oops, it's not going to be positive 2 though, because when you take plus 2 and you move it to the other side, it becomes negative 2. So we're going to subtract 2. In addition to that, I'm going to take this 4 and I'm going to distribute it. So I'm going to have 4x minus 20 and then minus 2. So that's going to be y is equal to 4x minus 22. Now, what that form is what we call slope-intercept form, where you have y equals mx plus b. But I don't want that form. I want standard form, okay? This is standard form, where the ax plus by equals c. So that means, see this 4x? I'm going to move it to the other side. So now it's at negative 4x. Plus y is equal to negative 22. Well, now, see how my x's and y's are on the same side? Now I have my x and y on the same side. The only problem is that my x coefficient is negative. So I'm going to multiply the entire equation by negative 1. And in doing that, I'm going to get positive 4x minus y is equal to 22. And that's in standard form. Cool. All right. So the next thing we want to do is I want to do this, but this is now, I'm going to give you a fraction, okay? So I still want to put it in standard form, but I still have point slope, okay? So we're going to go, let's see here, y plus 3 is equal to 1/2 times x plus 1, okay? Standard form, we need to solve for y to get there. We need to go through slope-intercept form, remember? Solve for y. So we have y equals, now I'm going to distribute here, and then this plus 3, I'm moving to the other side. So there it is right there. So distributing this, 1/2 times x is 1/2 x, 1/2 times 1 is plus 1/2, minus 3. Now, see these two numbers? We need to combine those. So in order to combine those, they need a common denominator, which means I'm going to multiply by 1. Now, keep in mind, 1 comes in many forms. I'm going to multiply it by 2 over 2. That way I'm not changing the problem. It's just multiplying by 1. So now what I'm going to have is 1 minus 6. What's 1 minus 6 is negative 5. And then halves. So y equals 1/2 x minus 5 halves. Now, I'm almost in standard form. This value needs to move over here because remember, in standard form, ax plus by is equal to c. That's standard form. And for something to be in standard form, this a term needs to be positive and it needs to be a whole number. I'm going to move this over. I get negative 1/2 x plus y is equal to negative 5 halves. Now, not only is my a term negative, but it's also a fraction. So I need to do some damage control here, and we're going to multiply the entire equation by negative 2. And when I multiply this by negative 2, see negative 2 times negative 1/2, this is over 1. 2's are going to cancel, negatives are going to cancel, and it's 1. So I have 1x. But keep in mind, see this negative 2? That also gets multiplied by this and that. So negative 2 times y is just negative 2y. And negative 2 times negative, so remember, negative 2 times negative 5 halves. Oops, I don't know if you can see that. Negative 2 times negative 5 halves, put a 1 under there. 2 negatives plus 2 cancels with 2. I get 1 times 5, which is 5. So now this is in standard form, and that's what we wanted. Okay. All right. Now we have 2 points, and we want to find the equation of the line again in standard form. The trick to this, though, is I have 2 points. I need to pick a point. So pick your favorite point. I'm going to do both. So we got y minus 4 equals my slope, which I don't know what that is yet, times x plus 3. However, if I chose the other point, I would have y plus 1 equals my slope times x minus 6. Something to consider is you don't have to do this twice. Pick one way and stick with it. I'm just showing you both ways just for fun. I need a slope. See this m? That's a slope. Same slope. Same line, same slope. Slope, subtract your y's over subtract your x's. That's that change in y over the change in x, which basically means that's your slope. Okay? Subtract your y's over subtract your x's. So negative 1 minus 4 over, see this? Negative 1 minus 4, and now I have to go 6 minus negative 3. 6 minus negative 3. So that's going to give me, it looks like negative 5 over 9. So that's my slope. So we have y minus 4 is equal to negative 5/9, so negative 5 over 9 times x plus 3. Same thing on this side. We're going to have, let's see here, y plus 1 equals negative 5/9 times x minus 6. I'm going to distribute, and this negative 4 is going to come over to the other side. So we have negative 5/9 times x, which is negative 5/9 x, and negative 5/9 times 3. So let's see here. Negative 5 over 9 times 3, 3 cancels. That makes negative 5/3. But don't forget this minus 4, when I bring it to the other side, becomes plus 4. And I need a common denominator. So that's going to be multiplying by 1 in the form of 3 over 3. So that's 12. 12 minus 5 is 7. So we have y equals negative 5/9 x. Negative 5 plus 12 is 7, so plus 7 over 3. I need to move this to the other side. So now I have 5 over 9x plus y equals 7/3. This is a mess. What's a mess is that my x coordinate is not only not a fraction, and that's not nice. So 9 times 5/9, 9s are going to cancel. We get 5x. 9 times y is plus 9y. 9 times this. Okay, so that's going to be 9 times 7/3. 3 goes into 9, 3. 3 times 7 is 21. And so here we are in standard form. You can keep working this out. I would get, let's see, y equals negative 5/9 x minus 30 over 9 minus 1, which is 9/9. And what I need to do is divide by 3 and then multiply. So you can keep working that out. Keep in mind the same answer that you're going to get is this one right here. Okay, I guess I could keep working it out. Equals negative 5/9 x. This is negative 30. Oh, maybe I should just reduce that. Anyway, negative 30 over 9. What does that make? Let's divide by 3, and I get 10/3. So I get negative 10/3 minus 1. This is going to need to be, what, 3/3? And then, anyway, negative 13, and move it over to the other side. Yeah, you can work that out. I'm not going to finish that. There is one other thing. There is a Kahoot that's kind of cool that you can work out, but that you can play if you just pause this and then type this in. You can look at the Kahoot. But there's one other problem that I wanted to do, and this was given, let's see here, given this point, which is, let's say, negative 3, 2. And let's say that's my midpoint, okay? And you're given the midpoint, and let's say 1, 4. So if I were graphing this, I'd have negative 3 up 2. So here's this point here. And I would have, and that's my midpoint. And then I would have the point 1, 4. So 1, 1, 2, 3, 4. Here's this point, 1, 4. This point here, negative 3, 2. What I want to know is, what's the other point? Okay. Now, if this is my midpoint and this is an endpoint, that means that my other point needs to be somewhere over here. Okay. Now, a lot of kids, students, people will count and they'll go like, okay, down, over to get this point, which is fine. But sometimes the points are like halves or something like that. So you want to be able to find this value here, x, y. So in order to find that, let me show you. You're going to take the average. So you're going to go x plus 1 divided by 2 is equal to the x coordinate of the midpoint. And to find the y value, you're going to go y plus 4. See this, y plus 4, find the average, divided by 2 is equal to the y coordinate, which is 2. And in solving this, I'm going to cross multiply, and I'm going to go x plus 1. So I'm going to have x plus 1 is equal to negative 6. So x equals negative 7, because I'm going to subtract 1 from both sides. And then cross multiply here, I'm going to get y plus 4 equals 4. And so y is equal to 0. So this point is going to be negative 7, 0. And so that's the other endpoint. So definitely you need to know how to do that. And I just don't remember doing any of those problems as samples, so I wanted to do that. So I hope that helps you, and thanks for watching.